Hello guys, today I'm going to talk about 1975. Okay, it's not the year, of course, like it's the Leetcode 1975 problem, maximum matrix sum. So this problem actually reminds me one of the instance in my university days when I clearly remember there was a walk-in, okay, and there was a question. If one chocolate costs 4 rupees, how much five chocolate will cost? And you may not believe there are options like 20, 25, 23, and all those, different options were there. And I have heard people writing 25, 23, and not 20. So this is the problem, right? When you prepare too much or, when you uh, see such a simple question from a big organization, you think that there might be something else. Okay, I don't know. Maybe this cannot be such a simple question that TCS or Google or Amazon will ask, right? When you look at this 1975, this LeetCode 1975 problem, I think people will think as if this is such a complex problem, okay? Because it deals with matrix, and when you look at the examples again, you think that, oh my God, it might be a DFS problem. I also thought about like, okay, it might be a very complex problem, but it turned out to be a very simple problem actually. So let's just read this question and start the solution, okay? So you are given a n cross n integer matrix. You can do the following operation any number of times. Choose any two adjacent elements of matrix and multiply each of them by -1. So it's telling take two adjacent elements, okay, and multiply each of them by -1, okay? Two elements are considered adjacent if and only if they share a border, okay? Your goal is to maximize the summation of the matrix elements, return the maximum sum of the matrix elements using the operation mentioned above. Okay, so we have to maximize the summation of the matrix elements, okay? Okay, good. And we have to choose two elements, adjacent elements, and multiply each of them by -1, okay? Cool. And we have to maximize the sum, okay? There are few numbers in a matrix. Matrix is nothing but again a two-dimensional array, okay? If all the elements in arrays are positive, then you don't have to multiply -1 with anyone actually. You just sum all of them and you get the maximum number, right? If there are few numbers negative, right? Then you have to multiply -1, right? And the property of -1 is like, okay, negative number, -1, you multiply with a negative number, it becomes positive, right? If you think a little more, you will realize that if I multiply -1 with -1 two times, then it becomes a positive number, and that positive number multiplied with any positive number will give you the maximum result, right? Which means if there are even number of negative numbers in the array, then you are fine. You actually just by summing all the numbers, right? All the numbers, you will get the maximum number, okay? So if the array has even number of negative numbers, then summing all the absolute value of the elements will give you the maximum result, okay? The problem will be there only if there are odd number of negative numbers, okay? And that is the only edge case here. Let's look at the editorial solution. It's explaining so much, but yeah, this is the gist, guys. If there are odd number of negative numbers, then we have to do a small special case here. Okay, and what is that? Going back to the example, okay, I will take you to the second example. Okay, second example is actually a better example because the first example only deals with -1 and only 1. Okay, this is a better example. So let's see. In the second example, if you look at the second row has negative numbers, and we are allowed to choose two adjacent elements to get multiplied with -1, right? We'll multiply with -1, maximize it. So if there are odd numbers of negative numbers, then pick the smallest. Okay, it's not the smallest element. Actually, it's the largest element, right? -1 is the largest element, not -2, -3, right? So yeah, pick the largest element, right? Or maybe you can say the smallest absolute value of the element in the array. Keep track of that. So this matrix total sum is how much? This is 6, right? So 6 multiplied by 3 is 18. Okay. So now we are not considering this number. So our total sum will be, this is 6, 6 plus 6, 12, 12 plus 5, it's 17, right? But we are actually going to get the total sum. This is the question, right? We are not just skipping this number, considering this number, we are going to find the total sum of the matrix, right? So total sum is how much? Total sum is -1 has to be added with the total sum again, right? So from the total sum, first we removed the absolute value of the minimum number, minimum negative number, right? Which is 1. Minimum negative number is -1. Its absolute value is 1. So we deduct 1 first from the total sum, right? And after that, we add this number, right? So -1, right? Because we are going to get the total sum of the matrix. So we are actually doing 2 times deduction of the minimum value, right? Isn't it? Let me know if you are not clear, but I think this is straightforward, because the fact that we have added it in the total sum first you remove that, okay? And then we still have to add that number again to get the total sum. But that number is negative. That's why we are doing 2 times deduction, okay? So that's the solution, guys. We are going to do 2 times deduction if negative count %2 not equal to 0. That means odd number of negative numbers are there. Then we already have the total sum here. So first step is total sum equal to total sum minus the minimum absolute value. This is first thing, okay, as I told you. And then again, total sum will be what? Total sum plus the minimum value, not the absolute value. But we have actually lost that in this particular process in the for loop, and we are saving that in the form of minimum absolute value. That's why I'm going to deduct that minimum absolute value again, because its sign is negative. Okay, just remember that. So that's why 2 times we are deducting, 2 times minimum absolute value we are deducting from the total sum. Okay, and that's your answer, guys. Let's run it. Let's submit it. Cool. That's the answer, guys. Okay. And the time complexity is, of course, like, the total number of element in the matrix. Okay. You can say m cross n or total number of elements in the matrix.